Hello everyone, Assalamu alaikum. My name is Hasibur Rahman and my ID is 181151134. Welcome to my video presentation. Today my video presentation topic is pin diagram of 8086 register. 8086 register, Intel 8086. Intel 8086 was launched in 1978. It was the first 16-bit microprocessor. The microprocessor had major improvement over the execution speed of 8085. It is available as 40-pin dual inline package DIP. It is available in three versions: 8086 5 MHz, 8086 8 MHz, 8086 110 MHz. It consists of 29,000 transistors. Each has a 16-bit data line bus and a 20-line address bus. It could address up to 1 MB of memory. Each has more than 20,000 instructions. It supports multiplication and division. Now pin diagram of 8086, AD0 to AD15. These lines are multiplexed by directional address data bus. During T1 they carry lower order 16-bit address. In the remaining clock cycle they carry 16-bit data. AD0 to AD7 carry lower order byte of data. AD8 to AD15 carry higher order byte of data. A19 by S6, A18 by S5, A17 by S4, A16 by S3. These lines are multiplexed on directional address and status bar. During T1 they carry higher order 4-bit address. In the remaining clock cycle they carry status signal. BHE. BHE stands for bus high enable. BHE signal is used to indicate the transfer of data over higher order bus data bus D08 to D15. 8-bit IO device use the signal. It is multiplexed with status pin S7. RD, read. It is a read signal used for read operation. It is an output signal. It is an active low signal. Ready. This is an acknowledgement signal from slower IO device of memory. Reset. It is a system reset. It is an active high signal when high microprocessor enters into the reset state and terminates the current activity. It must be active for at least 4 clock cycles to reset the microprocessor. INTR. It is the interrupt request signal. It is the active high. NMI. It is a non-maskable interrupt signal. It is an active high. Test. It is used to test the status of math coprocessor 8087. The busy pin of 8087 is connected to the pin 8086. If low execution continues, else microprocessor is in wait state. Clock. The clock input provides the basic timing for processor operation. It is symmetric square wave with a 33% duty cycle. The range of frequency of different version is 5 MHz, 8 MHz and 10 MHz. INTA. This is an interrupt acknowledge signal. When microprocessor received a INTR signal, it acknowledges the interrupt by generating this signal. It is an active low signal. DEN. This is a data enable signal. This signal is used to enable the transceiver 8286. DT by R bar. This is a data transmit or receive signal. It decides the direction of data flow through the transceiver. M by IO. This signal is issued by the microprocessor to distinguish memory access from the IO device. WR bar. It is write signal. It is used to write data in memory or output service depending on the status. M by IO signal. HLDA. The HLDA is a hold acknowledgement signal. It is issued after receiving the hold signal. When DMA controller needs to use address or data bus, it sends a request to the CPU through this pin. QS1 and QS0. These pins provide the status of instruction queue. S0 bar, S1 bar, S2 bar. This status signal indicates the operation being done by the microprocessor. The information of is required by the bus control 8288. RQ bar by ZT1 bar, RQ bar by ZT0 bar. These are request grant pins. Other processor request the CPU through these lines to release the system bus. The ready and wait state. The ready input cause wait state for slower memory and IO components. And this is all about from me about 8086 pin configuration. Thank you for watching my video presentation.